Welcome to our series on one of the most controversial theories of our time, the flat earth theory. Today, we're diving into the idea that the earth is not a sphere but a flat plane. We'll explore its origins, the arguments made by its proponents, and the scientific rebuttals to these claims. The flat earth theory is not new. Ancient civilizations, from the Egyptians to the Greeks, had their own interpretations of Earth's shape. But how did this ancient belief resurface in the modern age? The flat earth theory. Join us as we investigate the flat earth theory, its evidence, and the scientific counterarguments. Let's begin by exploring the origins and key concepts of this intriguing theory. Historical perspectives. To understand the flat earth theory, we must first look at its historical roots. Ancient civilizations often depicted the earth as flat. For example, the ancient Greeks believed in a flat, circular earth with a dome above it. As science progressed, figures like Copernicus and Galileo challenged these flat earth models, leading to the widely accepted spherical earth theory. But what caused this transition? Exploration and empirical evidence slowly replaced ancient beliefs with a spherical earth model. Yet, in recent years, the flat earth theory has gained new traction. Why is this theory making a comeback? In the next part, we'll look at the evidence presented by flat earth proponents and the arguments they use to challenge the spherical earth model. Evidence presented by flat earthers. Flat earth proponents present a variety of claims to support their theory. From visual evidence to scientific arguments, let's examine what they say. Some flat earthers argue that images from space are doctored, and that the horizon appears flat, not curved. They also conduct experiments, such as measuring the angle of the horizon from different heights. We'll explore their experiments and claims, but how reliable is this evidence? Next, we'll delve into the scientific rebuttals and counter-evidence. Scientific rebuttals and counter-evidence. Science provides substantial evidence supporting a spherical Earth. Satellite images, gravitational studies, and observations from space missions all reinforce this view. Gravitational physics and the curvature of the Earth can be observed in various ways, such as how ships disappear hull first over the horizon or how time zones work. Experts in astronomy and physics explain why the spherical Earth model holds up against flat Earth claims. Misconceptions and logical fallacies are addressed to clarify why the scientific consensus supports a round Earth. Cultural and psychological aspects. Why do some people cling to the flat Earth theory despite overwhelming evidence to the contrary? Understanding the psychological and cultural factors is key. Psychological factors such as cognitive biases and distrust in authorities play a significant role. Online communities and influencers also amplify these beliefs, creating echo chambers that reinforce flat Earth ideas. We encourage you to engage with credible sources and approach conspiracy theories with a critical mind. Knowledge and skepticism are powerful tools in discerning truth from fiction. The history and origins of flat Earth beliefs. The concept of a flat Earth is not a new one. It finds its roots in the ancient civilizations of our past. Many of these early societies depicted the Earth as a flat expanse, surrounded by vast oceans that stretched into infinity. This visualization was not only a reflection of their observations but also intertwined with their mythological and religious beliefs. As time progressed, the narrative of a flat, stationary Earth became embedded in various cultures around the world. Despite this early worldview, significant advancements in Greek philosophy and science challenged these notions. Figures such as Pythagoras and later Aristotle began to propose the idea of a spherical Earth, grounding their arguments in empirical observations like the changing phases of the moon and the behavior of celestial bodies. These early dissenters laid the groundwork for our current understanding of Earth's shape, signaling a pivotal shift away from flat Earth theories. Misinterpretation of scientific evidence by flat earthers. Flat earthers are notorious for their selective use of scientific data to back their assertions, often engaging in a deliberate distortion of facts to suit their agenda. They might, for example, point to the absence of perceptible curvature from certain vantage points as proof the Earth is flat, disregarding the principles of physics that explain why the curvature is not always visible to the naked eye. This manipulation extends to a misunderstanding of basic physics, where they assert that if Earth were truly a globe, rivers such as the Nile would have to flow uphill to complete their course, blatantly ignoring the effects of gravity and the planet's immense size. Another common misrepresentation involves the use of flight paths, where flat earthers argue that certain direct flights would be impossible on a spherical Earth, without accounting for the fact that great circle routes' shortest paths between 2 points on a sphere often appear curved on the two-dimensional maps they rely on for this claim. The role of cognitive bias in flat Earth beliefs. Cognitive bias significantly influences the perpetuation of flat Earth beliefs among its proponents. Confirmation bias is a key factor. Individuals gravitate towards information and interpretations that affirm their preconceived notions, while conveniently dismissing or devaluing evidence that contradicts them. This phenomenon is not unique to flat Earth theories, but is particularly pronounced within this community. The allure of confirmation bias lies in its comfort. It reinforces one's worldview, providing a psychological shield against the cognitive dissonance that arises from conflicting information. The Dunning-Kruger effect further exacerbates the situation, leading individuals to overvalue their understanding and analytical capabilities, often to the point of rejecting established scientific consensus in favor of their own interpretations. This cognitive bias can create an overconfidence in one's ability to analyze complex scientific data and concepts, despite a lack of formal education or expertise in the field. It fosters an environment where subjective belief is mistakenly equated with objective fact, blurring the line between informed skepticism and willful ignorance. Debunking popular flat Earth myths with real science. Challenging the claim that the Earth's horizon appears flat. Science explains this through the concept of the observer's limited view due to the vast size of the planet. Flat Earth theory also misunderstands gravity's role, suggesting incorrectly that if Earth were round, people would fall off its underside. However, gravity pulls equally towards the center of the planet from all directions, allowing us to stand on its surface no matter our position. Additionally, lunar eclipses provide irrefutable evidence against a flat Earth. The Earth's brown shadow cast on the moon can only occur if the Earth is spherical. Observations during the lunar eclipse, when the Earth passes between the Sun and the Moon, clearly show a round shadow, contradicting the flat Earth claim that Earth's shadow should be flat. These scientific explanations debunk common misconceptions, illustrating that natural phenomena observed on Earth and in space align perfectly with the principles of a spherical Earth, not a flat one. Visual and mathematical evidence supporting a spherical Earth. One of the most compelling pieces of evidence for a spherical Earth comes from direct visual confirmation. Satellite images and photographs taken from space missions unequivocally depict the Earth as a globe, displaying its curved horizon in spherical shape. These images are not only profound because they offer a perspective unachievable from the Earth's surface, but they also eliminate the speculative nature of theoretical science with tangible, undeniable evidence. In addition to these visual affirmations, mathematical evidence strongly corroborates the spherical model of the Earth. Through geometry and trigonometry, calculations reveal how distances on Earth's surface, the curvature visible during long-distance flights, and the angles at which stars are observed from different latitudes all align perfectly with the globe. The way ships disappear hull first on the horizon and reappear mass first can only be accurately described using spherical geometry, further validating the Earth's roundness. Why the flat Earth theory persists despite scientific evidence. The endurance of flat Earth theory, even in the face of extensive scientific evidence to the contrary, can often be attributed to a deep-rooted skepticism towards established institutions and scientific authorities. Many adherents are drawn to the flat Earth community as a form of rebellion against what they perceive as elitist and untrustworthy scientific consensus. This skepticism is compounded by the echo chambers of social media, where misinformation can spread unchecked, and confirmation bias reinforces pre-existing beliefs. Additionally, the flat Earth theory offers a simplistic view of the world that is appealing to some, as it provides straightforward answers to complex questions about our planet and its place in the universe. The psychological appeal of being part of a community that shares and validates unconventional views cannot be underestimated. This sense of belonging and identity within the flat Earth movement plays a significant role in its persistence, as it offers social support and camaraderie to its members, who may feel alienated or disenfranchised by mainstream science and society. Engaging constructively with flat Earth believers. Conversations with those holding flat Earth views should be navigated with care, emphasizing empathy and a genuine willingness to understand their perspective. Instead of dismissing or belittling their beliefs, aim to create a dialogue where scientific evidence can be discussed openly and calmly. It's beneficial to frame the conversation in a way that encourages questioning and exploration, rather than confrontation. One effective strategy is to use questions that prompt critical thinking and self-reflection, such as asking how they came to support flat Earth theory or what kind of evidence would be necessary to change their view. This approach can help in steering the discussion towards a more productive exchange of ideas. Offering accessible and easy-to-understand scientific explanations is also crucial. Many flat earth adherents may not have a background in science, so breaking down complex concepts into simpler terms can aid in bridging the gap in understanding. Share resources like articles, videos, or infographics that concisely explain the evidence supporting a spherical Earth. Additionally, highlighting the joy and wonder of scientific discovery can be a powerful tool. Rather than framing the conversation as a battle to be won, presenting it as an opportunity to explore the mysteries of our universe together can foster a more open and positive exchange. Thank you for joining us on this exploration of the flat Earth theory. We hope this series has provided clarity and insight into this fascinating topic. Stay curious and keep questioning.